Today's revision video is looking at trigonometric ratios and using them to solve triangle problems. So the question here is on the guided practice slide from the PowerPoint that I've sent out to you. So you should have read the question, and I've actually put here the cosine rule, the sine rule and the formula for the area of any triangle. These three equations are something that you are expected to know once you go into your exam. So this shouldn't be new to you. You've seen them all at GCSE and you've seen them this year. So the question says, the diagram shows the locations of 4 mobile phone masts in a field. It says in order that the masts do not interfere with each other, they must be at least 70 metres apart. It says given that A is the minimum distance from D, find, first of all, the distance AB. So we are told that A is minimum distance from D. And we are also told that they need to be at least 70 metres apart. So AD must be 70 metres. I'm just going to add that to my diagram before I even start part A. So part A, we want to find the distance from A to B. So we're going to use the cosine rule to find out this distance by splitting up this quadrilateral into 2 triangles. So if I draw a line going from B to D, we are then going to be looking at the triangle BCD to find the angle of BDA. So to find out this angle here. Once we found this angle here, and we found this length here, we will be able to use the cosine rule for this triangle. So we're going to, first of all, find that length BD. So BD squared, that's equal to BC squared plus CD squared, subtract 2 BC CD cos, and we're looking at the angle BCD. So we're looking at this triangle here. I've used the cosine rule to find out this length here. So essentially, this is lowercase b, this is lowercase c, and we've got this as our angle capital A, if we were looking at that formula. So BD squared is equal to 75 squared plus 80 squared, subtract 2 multiplied by 75 multiplied by 80 multiplied by cos 55. If I put that into my calculator, I get that BD squared is equal to 5,142.08 and so on. I'm going to then square root that, so the square root of BD squared, and I get 71.708 and so on. So I've found a length for BD. I now need to find the angle ADB in order to find that length AB. So we're going to use the sine rule here. So we're going to do the sine rule for sine of the angle BDC, so the angle BDC, which is this angle here, that's over the length BC, so this angle over that length, that's going to be equal to sine BCD over the length we have just found, BD. So if we were to rearrange this, the angle that we want to find out is this angle here, so we can find out that angle there. So sine of BDC, that is equal to sine of angle BCD over BD multiplied by BC. Now when we actually input the values, we've got sine of BCD is angle 55. BD is the length we just found out. And BC is given in the question, that's 75. So we get, once we put this into our calculator, we get an answer of 58.954 and so on. So the angle BDA, this angle here, BDA, that is equal to the angle CDA, the whole angle, 140, subtract the angle BDC, which we've just found out, which is equal to 81.045. So I'm just going to write down what we've just figured out. So we found that this angle here is around 81.045, and we found out that that length there was 71.708 metres. So now looking at this diagram, in order to find the distance from A to B, we can use the cosine rule, looking at these two lengths and that angle there. So using the cosine rule for that, we're going to find out what AB squared is. So AB squared is equal to AD squared plus BD squared, that length we found at the beginning, subtract 2 AD BD cos angle BDA, the angle we've also just found out. So AD BD angle BDA. So this is equal to 70 squared plus 71.708 squared, subtract 2 times 70 times 71.708 multiplied by cos 81.045, which is equal to 8,479.55 when you put that into your calculator. So then AB, we want to do the square root of AB squared, which is equal to 92.1 metres to 3 significant figures. So this question asked for that length AB. We needed to look at our cosine rule, sine rule, and decide what information we needed in order to find AB. Well, to use the cosine rule, we needed these two lengths and that angle. So we had to use the information from this part of the diagram to work out that length and then work out that angle. So there was a lot of steps to it which you weren't told to do, but it's looking at the diagram, looking at your equations, figuring out what you can find out, and understanding that we're solving triangle problems, so we're going to have to split the quadrilateral into two triangles. Part B of this question asks us to find the angle BAD, which I've just marked as that blue angle there. We've just found the length AB, which was 92.1. So now looking at this left-hand side triangle, we want the angle BAD. We know its opposite length. We've got this angle here in the triangle and the opposite length AB, which means we can use the sine rule. So sine of angle BAD over the length BD is equal to sine of the angle ADB over the length AB. So to find out sine of angle BAD, we're going to multiply this side by BD. So sine of angle ADB, which is 81.045, over AB, that is 92.1, and we're multiplying it by BD, which is 71.708. When you put that into your calculator, you should get 0.769. So sine of angle BAD is equal to 0.769, which means to find the angle BAD, we're going to do sine inverse of 0.769, which is equal to 50.3 to 3 significant figures. Part C of our question is asking us to find the area of the whole quadrilateral, so area ABCD. Now, obviously the area of that quadrilateral is the sum of the area of the two triangles. So it is equal to the area BCD, triangle BCD, plus the area of BDA. So we're going to use that area formula. So first of all, area BCD, we've got a half multiplied by BC multiplied by CD multiplied by sine angle BCD. So we've got, for BCD, we've got half multiplied by this length, and the sine of that angle. So that is equal to a half multiplied by 75 multiplied by 80 multiplied by sine 55, which is equal to 2457.4. Area BDA, that's equal to a half multiplied by AB multiplied by AD multiplied by sine of angle BAD. So we're doing a half multiplied by AB, AD, and then we're doing sine of this angle, which is the angle we just found in part B. So that is equal to a half times 92.084 times 70 times sine of 50.28 or 50.3. I'm just using the value before I rounded it up to 3 significant figures to remain accuracy, which is equal to 2479.2. So then the area ABCD is the sum of these two areas, which is equal to 4,940 metres squared to 3 significant figures.